Hi, this is Ramu, Associate Professor, Department of CSC, Institute of Aeronautical Engineering, Hyderabad. Today we are going to see problems on two-dimensional arrays. See, in today's class we are going to concentrate on transpose of given matrix and printing the lower triangle of the given matrix and printing the diagonal elements of a given matrix. First, we will see how to read the matrix, and next we'll perform some operations, the given operations on the matrices. Right? First, if you want to, so just now we have seen that how the single dimensional arrays are going to work. If you want to read the single dimensional arrays, you require one for loop. But here the two dimension means you require two for loops, means one for loop for the number of rows and one for loop for the number of columns. Right? We'll see. First, you can take that one array, an array into of M is a matrix of, so 10 by 10 matrix. It is going to take that, so small m, number of rows, number of columns, right? Row count and column count, these are the values are required. Right? First, what we need to do here, I'm going to read the array matrix, right? So that scanf of number of rows, right, and number of columns. This is there in the m comma n. M comma n. Right? So should use ampersand, otherwise you will get unwanted numbers. Yes. Now read mn values. Next, my task is to read that number of elements. For example, 3 by 3 means how many elements are required? 3 by 3. M value is 3 and n value is 3 means, so it contains E1, E2, E3, right? E4, E5, E6, right? E7, E8, E9. Yes or no? These are the elements for the 3 by 3 matrix. 3 by 3 matrix. So this index is 0, right? This is a 0 index, 0, 1, 2. This is also 0, 1, 2. Means this is the 0, 0 index, right? This is the 0, 1 index, and this is the 0, 2 index. This is the 1, 0 index, 1, 1 index, 1, 2 index, 2, 0 index, 2, 1 index, 2, 2 index. Right? Please note this. This is the number of rows. You can represent with the I. Number of columns, you can represent with the J here. Right? See how I am going to read. Now, I want to start with the rows, right? For I equal to 0, from 0 to until row. So, row is there at M, right? I plus plus. After this, what do you do? First row, all columns. Second row, all columns. Third row, all columns. Yes or no? For that, I'm going to write for j equal to z, for j equal to 0, right? J is less than n and j plus plus. After this, scanf of percentage d, comma, ampersand. Please note this, ampersand, m of I, right? 0, 0. Next, j. Right? See, this is the way you're going to read the array. For example, if you want to print the data, print the matrix, you can use the same thing. Here, instead of that, you can use a printf. Printf. Right? But please remember, every row, after every row, you need to go to the next line. Yes or no? Should go to the next line. So for that reason, what I'm going to do here, see, after this printing statement, I just use printf of /m. See, if you run this code, see, 3 by 3, right? And elements 1, 2, 3, 4, 5, 6, 7, 8, 9. See what it printed. The reason is why it is printed means the reason is here you used ampersand. That is the reason. Use ampersand. What did you use? Ampersand means address, right? Yes or no? Got it? Got it? Row wise and column wise. Got it? Now our task. What is our task? Our task is to transpose. Transpose. Transpose means rows, columns, columns, rows. Yes or no? Rows values goes to column and column values goes to rows. That is our task. See. For that reason, see, I'm simply I'm going to find out all lower matrices. See, all lower matrices, and that matrices are updated with the upper matrices and the lower matrices. That's all. See, for that, you just use the same concept. So after printing, you can take that the same for loops. Please note this. So first 0 0, right? 0 0 is replaced with 0 0 only, right? 0 1 and 0 2 0 3, right? Next 2 2 like that, right? So here instead of n, instead of n, instead of n, here you can use n, right? So instead of m n, you can keep it. It is not an issue. First time it is going to be the all the up to n, right? Next time it is going to reduce, right? Yes sir. It is going to reduce, right? For example, 2 3 4 6 5 7, right? What do you need to do here? See, 2 2 is replaces 2 2 only. Here 3, right? 2 3 is goes to 2 3, right? 4 6, right? 5 7, 2 4 5 3 6, yeah, 3 6 6. Got it? This is our output. So what do you need to do here? So changing of the values changing, right? Here, how to repeat that value? Please note this. See, the same thing you need to change, right? So here I'm going to take some temporary variable t, right? The t, see, the t is, so t equal to, so here please remember the changing of the values, the changing of the values. For example, it is a diagonal. So for example, 2 3 4 5 6 7 8 9 10, right? So this 8 is replaced with 4, so 3 is replaced with this one, and 9 is replaced with this one, right? Because of the only this triangle, these values, right? If you change the two things, it's enough. Yes or no? It's enough. But if it is not diagonal, so it is not square. If it is not square, then you will get a problem that time. You'll get a problem at that particular time. So what I need to do here? See what I need to do that time. Here, what I'm going to do, t equal to, so whatever it may be, that I treated that is the diagonal only. It is a diagonal only. See, it is a diagonal only. m minus i, means the first time it is going to be that many rows, and it reducing, right? So which is the largest? That is simply you can take that value. See, next time, see, observe clearly. T equal to, so m of t equal to m of ij, right? I'm going to take m of ij ij equal to m of ij equal to m of ji, m of ji. Next, see, next, m of I, m of j, m of ji equal to, see, this within matrix I am going to changing the value. See, that value is t. That's all. Right? Let us see. Is it you the right answer or not? 3 by 3. 1, 2, 3, 4, 5, 6, 7. See, 1, 2, 3, 4, 5, 6, 1, 8, 7, 8, 9, right? So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Reading the same thing, right? Yeah. What the mistakes you have done here? M of ij. So 0, 0 comes to here, right? And this is the diagonal only. Then you're still getting the problem. Why? So 0, 0, 0, 0 is replaced with 0, 0, and 0, 1 is replaced with 1, 0, 1, 0, right? 1, right? So we'll get the 2 by 2, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. We're getting the same output. Ij value stored at t, right? Ij equal to ji, and ji, m of ji equal to t. And next thing, so should change the values, right? That's all. 1, 2, 2, 1, 2, 3, 4. Got it? See, the diagonal of the elements. Is this clear? Is this clear? So it's a transpose. This is the transpose. Next, my task is, what is my task? So printing the lower triangle. Lower triangle. So lower triangle means, please remember, lower triangle even. So lower triangle contains, see, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. Means lower triangle means you should consider this one. Right? Lower triangle. So here, the lower triangle, please remember, so all your rows and columns, see, here 0, 0 is there, here 0, 1 is there, here 0, 2 is there, here 1, 1, sorry, 1, 0 and 1, 1. What you observe? Here 1, 2 is there, and here 2, 0, 2, 1, 2, 2. Means always row is greater than or equal to column, right? You just use that message, that's all. This is not required. See, here while printing, only if I value is greater than or equal to j, that's all. See, if you run this code, only one change is required. 1, 2, 3, 4, 5, 6, 7, 8, 9. See, 4, 5, 6. See, this is the diagonal, right? Yes or no? 1, 2, 5, 3, 9. This is the diagonal. Lower triangle. If you want upper triangle, you can use I less than or equal to j. That's all. You will get the upper triangle. The small change we'll get the upper triangle, lower triangle. Okay. What is the next task? The next task is finding all the diagonal elements, printing the diagonal elements. For the diagonal elements, you didn't require this one. So only m of I, that's all. It's enough. See, if you run this code, 3 by 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. See, these are the diagonal elements. This is the given array. Right? 1, 5, 9. What I did? I'm going to print 0, 0, 1, 1, 2, 2. The reason is, first one is contained 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Right? Here, our task is to print the diagonal elements. Diagonal elements, row and column size values are equal. That is why I'm going to get this value. Got it? 159. Is this clear? This is the printing of diagonal elements. Right? Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.